Guys, so welcome back to my channel called Shiba, where I'll be posting about DSS solutions, lead code solutions each and every day. And today is day 5th of doing so. And today we'll be solving a problem named sort colors, which is lead code 75. And let's directly jump down to the problem and see what it is. So, I'm given an array nums with an object colored red, white, blue. Okay. So, okay. So we can't use a sorting function. Hmm. Constraints are value of norms like n. Hmm. Okay. So what problem tells us that, let's take an example. First of all, 202.110. So what problem asks us is that we will be given with an array in which there are three elements. Three elements are 0, 1 or 2. The array consists of only these three elements, and we're required to sort this array without using any library sorting functions. In C++, it is sort and then arr dot begin arr dot end, and we are not required to use this one. Use this. So what can we do right now? If you're not required to use this sorting function, we can implement the sorting techniques such as insertion sort, bubble sort, merge sort, etc. Whatever kind of sorting techniques you might be knowing. And the second approach that I think is kind of useful is using hash map, where you can keep count of 0 or 1, any of the two unique elements inside the array. You can take count of 0 or 1, and then what we can definitely do is we can take an array, or we can manipulate the original array, such as the count of 0 and count of 1. First we can just take out the count of 0, and then we can take out the count of 1, and for that iterations we can insert values. Let's say 0 is 2 times, 1 is also 2 times here, and now since n is 6 and the last element is at fifth position, we can just subtract, like there are 6 elements and we have 4 elements right here, so we can just add the count of these two elements and we can subtract it by n. We will get 2 as the result, so number of 2's are 2. So this is how we can obviously get our answer. This is one of the ways. The thing is that first of all we will need to have a for loop for inserting all the elements count, and then we will also have to iterate for zeroth number of times for when n count number of times, right? And this is all of what we will be doing. Also it will have a time complexity, of overall big of n. It will take big of n, but there will be space complexity too, because of the hash map that we are using. It should also be big of n. So we will have this much time and space complexity. And but like a better solution than using a hash map is using an algorithm which is specifically designed to this problem, which is specifically designed to solve this kind of a problem, is known as the Dutch flag algorithm. Dutch flag algorithm. So how many colors are there? Red, white, or blue? I don't really know how Dutch flag is designed, but I'm sure like these colors are used: red, white, and blue. Okay, so I have both of the I have these three colors: red, then we will have white, and then we will have blue. Yeah, it looks like a flag now. So Dutch flag algorithm is specifically designed to solve this problem where an array consists of three elements is to be sorted. Okay, let's take the initial example that we had. Okay, so what we essentially do in this algorithm is that we take three pointers. We take three pointers. First is low, second is mid, and the third pointer is high. The third pointer is high. So we will have to initialize these pointers as low will be at the beginning, low and mid will be at the beginning, and high will be at the last index. Okay, so there are certain rules. There are certain rules that we need to follow. It's like kind of a game where we need to go while while we take care of the rules, while we go along with the rules how they are made. So the first rule states that like this whole flag algorithm revolves around mid. Keep this in mind. Whatever value is there at mid, we will be acting accordingly. So if the first case where mid is exactly equals to 0, what we will be doing? Will we increment our low pointer, and then we'll be incrementing our mid pointer too. Okay, that means like 0 should be in the low pointers place, so it's fine. Now the second rule of this problem is you will understand everything when I will do the dry run. So for now I'll just be telling you the rules. And let's say if mid is exactly at 1, which should be, what are we gonna do is we will just add mid, increment mid. Now the third condition and the last one is if mid is exactly equals to 2, what we will be doing is we'll be swapping. Okay, also yes, also we'll also use a swap function here where we will swap mid and low. And now here at the third condition, what we are gonna do is we will swap mid and high. Okay, and then we will decrease high by one position, and that's it. If we follow these three rules, all I'm telling you is we follow these three rules, our array will be sorted. So let's let's check it out. 202110. Let's check it out. 202110. Let's take our pointers low, mid, and high. Right now I'll be just telling you through by drawing. Okay, so let's say right now mid is at, where is mid? So mid is at 2. What we do when mid is at 2, we'll swap mid and high, and we will subtract high by 1. Okay, let's swap these two elements. It will be 0, and it will be 2, and then we'll subtract high by 1. Okay, so this is happening. Hmm. Now when we have mid's value at 0, what we do is swap low and mid. Since they're at the same position, nothing happens. We will add low and then we will add mid. Okay, so just add these two elements, low and mid. Again the condition is the same, low and mid. Okay, now 2, so we'll swap 1 and 2 here. We'll increment high. Will Okay, now we'll be at a position where mid's position carries 1, so we will just increment our mid, and it will be the same as high. Right now again 1 is here, and we will have to add mid. Now when this condition happens, like we will be running these three conditions till mid is smaller than or equal to high. If mid is greater than high, this condition will terminate, and we will be with our answer. So now if we take the current state of this array, we will see that we have two zeros, two ones, and two twos, and we are at the answer. So yeah, essentially we just need to follow these three rules, and we will be at our answer. Okay, so let me give you like a kind of a visualization of what is totally happening here. Within the array, what is happening is that mid will take all the values of ones, high will take all the values of twos, and low takes all the values of zeros. So what happens is that if there is any element at this point, if any element is there which is, let's say, 0, then we will swap it with low. If any element is here which is 1, then we will do nothing about it because it is at its correct position. If there is any element such as 2, then we will swap it with high. So essentially what is happening is that we are keeping each and every other element at its correct place, and then we are incrementing these pointers through which our array is getting sorted. Okay, now so this is everything which is needed to be explained. Now let's move down to the implementation and see if our code works, right? So now the first condition is when we have 0. It's not if else, it's else if. Okay. We will also need to swap at this position. Are we returning anything? No. So if there's nothing to return, we will do just this. Let's see if our code works. Mm, yes, so our code works fine. And let's submit it now. So yes, now we are at the solution. It beats 100%, so it's fine. Okay, thank you guys for watching my video, and I'm grateful to all the people who support me throughout this journey, and let's grow together. Okay, bye.